Great, so this is question 2.1. It's called remove dupes. And for this question, we just want to write code or a method here that will iterate through an unsorted linked list and just remove all the duplicates. So the first thing that I did was I just created this node class here, similar to the one described in the book. And we just have a constructor here that passes in the data that we're providing it, so what data is held within that node, and just a pointer to the next node. And I just have our driver program just creating 6 nodes, and it looks like this here. It's a linked list that's 2, 2, 3, 3, 3. And so you can kind of see the duplicates here. There's 2, 2, so we would want to remove this 2. And then there's 3 3s, so we just want to remove those 2 3s. So our expected result would look like this. Let's write that out, expected result. And this is just me linking the nodes and setting the next. And after that, I just have a quick print statement that after we're done, it'll just iterate through our list and print the result. So let's go ahead and create our algorithm here. So the first thing that we're going to use is a hash set. And what we want to do with this, and kind of our goal here, is to just write out our list again, is we're going to iterate through this list, and as we visit them, we're going to append them to our hash set. And so we visit the first node and put the value 1 in there. We visit the second node, we insert the value 2 in there. We visit the third node, and we notice that, okay, the value 2 is already contained within our hash set. And so we just want to remove that node from our list. And I'll explain that in just a second when we kind of create our algorithm. And then we want to iterate through the next one, and we see 3. We want to add that to our hash set. And then for the final 2 nodes, we notice, okay, 3 is already contained within our hash set. So we just remove those 2 nodes. Great, so let's create our hash set, but first we want to import it. So import java.util.hashset. Great. So hash set, just call it HS, and it'll be a hash set of integers just because we want to be storing the values of the nodes that we visited. And the next thing that we want to use is we're going to have a pointer to the previous node, and that'll be used later when we're wanting to delete a node from our list. So like most linked list problems, we're going to have a while loop, just checking while our current node does not equal null. So we're just iterating until we reach the end of the list. And the first thing we want to check is whether our hash set doesn't contain the current value, because then we're going to want to add it to our hash set. So if HS does not contain our current node's value, then obviously we're going to want to add it to our hash set. And then, since we just visited this node, we want to set our previous pointer, or this previous node that we have, to the current node because we just visited it. Next, what we want to do is, if we have already seen it, we're going to want to actually delete this node from our list. So that means it already has this node. Hash set contains this node. So let's delete it. And to do this, it's actually quite simple. We want to set our previous pointer's next node equal to our current node's next node. So I'll just quickly kind of illustrate what that looks like. So if we have our list again of 1, 2, 2, and then 3, 3, 3. When we iterate through here, so okay, 1, then 2, and then 3, and we noticed we already had the value 2 stored in our hash set. We're just going to say, okay, set our previous node, which is this one, who's next, to our current node's next one. So basically we just remove this node, and because we're setting this node's next one to our current node's next. Great, and so finally what we want to do is just at the end of this while loop, we just want to set our node equal to the next one, just so that we're iterating through this array, because we're not using like a for loop with an I iterating through like an array. Here we just want to be using node equal to node.next. Great, so let's run this code. And instead of node.value, just because in our class I call it data, we just want to change that to data. There we go. Great, and so 1, 2, 3, and that was our expected result. So the performance for this algorithm is it has a time complexity of O of n, and because we're using our hash set, we also have a space complexity of O of n, where n is the number of nodes in our lists, because worst case, if there isn't any duplicates, we would end up appending every single node's data point to our hash set. So there is another way you could do this. You could have a time complexity of O(n) squared and a space complexity of O of 1. That's kind of like the brute force way to do it, in my opinion. But there may be a circumstance to do that. It would essentially be like, a typical brute force searching method. So I think this is the better way to do it, but depends on your scenario. Anyways, I hope this helped, and have a great day.